What do we really mean when we talk about M1 benchmarking? Are we just comparing a single number, or is there a bigger picture we're missing? You've heard the headlines, M3 is 50% faster than M1. But for most of us, those synthetic numbers don't translate easily into our daily workflow. The real value of benchmarking is understanding performance trends, how one generation actually compares to the next, and more importantly, what that means for your work. The first key is realizing that M-series chips are not just about the CPU. They are a system on a chip, or SoC, which tightly integrates the CPU, GPU, and the neural engine. To compare performance effectively, you need a balanced view. Direct hit choosing the right metrics. When looking at M1 to M2, M3, or beyond, we typically use two kinds of tests. First, synthetic benchmarks like Geekbench give us clean, standardized numbers. Look at the single-core score for responsiveness in everyday tasks and the multi-core score for heavy lifting like rendering or compiling. A steady upward trend here shows Apple's consistent architecture improvements. Second, and more crucially, are real-world benchmarks. This is where we see the trend in application performance. Think about exporting a 4K video in Final Cut Pro, compiling a massive codebase in Xcode, or running complex filters in Photoshop. These tests show how the entire SoC, including the faster media engines and unified memory, works together. The true performance trend often appears much steeper in these real-world tests because the M-series specialty hardware accelerates these specific workflows dramatically. Hear the importance of consistency. When you're comparing performance trends, consistency is king. You can't compare a test run on an M1 MacBook Air with 8 gigs of RAM to an M3 Max with 36 gigs. You need an apples-to-apples comparison. Maintain a consistent testing environment. Operating system, use the latest stable Mac OS version on both devices. Software updates can significantly affect chip performance. Thermal conditions, ensure both laptops are running cool, typically connected to power, to avoid thermal throttling. This is when a chip intentionally slows down to manage heat, skewing results. Workload isolation, run one major benchmark at a time. Background apps, even small ones, can interfere with core allocation and memory usage. Finally, remember that the trend isn't just a straight line. The jump from M1 to M2 might be small for a simple task, but the shift from M2 to M3 might show a massive leap in a specific area like ray tracing or machine learning due to hardware accelerators. The performance trend is a story of targeted, specialized improvement, not just raw speed. Understanding the distinction is how you make a truly informed decision. With that said, thanks for watching and until next time.